Thank you everyone for being here. We are Abraham Rodriguez, Georgina Lemoya, and Jason Iwaneski, and we are excited to present, and Jonathan, and we're excited to present to you our Capstone project.
The objective of our project will be to develop a plan for next generation water resource recovery facilities, or WRFs. You may know them better as sewage treatment plants, the features of which will be energy efficiency, community involvement, and pollution control. Our core stakeholder is NYC DEP. Specific area of focus for us will be the 26th Ward WRF out in East New York. We're going to be examining the food, energy, water nexus out there and looking at it short-term through long-term considerations. Our work's building on a previous Capstone group who's wrapping up their work right now. They've provided us with fantastic background information, lots of it, and as well as some infrastructural elements proposed, and we look to evolve those systems.
Okay, so the wastewater treatment plant, 26th Ward, is located in East New York, and it's about 1/4 of the wastewater treatment plants located at Jamaica Bay's combined sewage watershed. Jamaica wastewater treatment plant, the Rockaway wastewater treatment plant, and Coney Island. So due to the CSO during wet weather conditions at the Jamaica Bay experiences poor water quality, which contributes to marshland erosions. So the Department of Environmental Protection has been solidifying plans to improve CSO long-term planning from 2008. In East New York specifically, it's a population of about 190,000 people. With 50% Black, 30% Latino, and 70% Asian. And some of the community needs in East New York is for affordable housing, cultural, and unemployment. As we can see here, this is some of the accessibilities. The cyan color is for bike lane, and the wastewater treatment plant is located right up north of Belt Parkway. Okay. Green space infrastructure adjacent to the wastewater treatment plant at 26th Ward is the Fountain landfill and the Pennsylvania landfill, and other initiatives for Fresh Creek Nature Preserve, which it's going to be part to create connectivity to the wastewater treatment. Okay, so the adjacencies such as Spring Creek Towers and New Lots are residential, and the Gateway Shopping Center is a commercial district. So what we're looking at here is a conceptual diagram that we developed to better understand the food and energy and water nexuses at the 26th Ward. So the 26th Ward, as you can see in the dotted area, is the existing processes of wastewater treatment. And the new programmatic elements that we have here, such as the MicroGrid, the Science and Technology Center, the food waste system, and the food hub. As well as floating living systems that we are potentially integrating as tertiary water treatment for Hendricks Creek. Next.
Okay, the energy component of our campus started mainly with questions. These were plant energy use, potential for energy recovery, ancillary services that can be provided, and how to reinforce community resilience. Next slide, please. For our background, we got a lot of our research from WRF, which is the Water, Environment, and Research Foundation. We were able to garner a couple of powerful things from these reports, namely the current energy position of New York City wastewater treatment facilities. These are explained through energy audits from a guide for utility leaders. They suggest to identify an energy champion and connect that leader across departments to release information that was stuck in silos. And for identification of barriers, they say it's typically financial, so we have to overcome financial constraints by exploring synergies and the cost savings they release into the plant systems. Next slide, please. Missing elements from this, this Huntington map. So this is a designed microgrid. It has not been completed, but it's around a Huntington wastewater treatment facility and a hospital and other healthcare, the YMCA, other community-facing elements. This next image you can see is the combined heat, no, not next slide, next image. The combined heat and power generator located at the Coney Island wastewater treatment facility. It's one of 4 engine generators that were installed over 25 years ago. In total, they provide 80% of total plant power needs, The derived heat is also used to offset a variety of plant heating loads. I'm going to skip that other one just for timing constraints. Please, next slide. Okay, this is our diagram of the microgrid component of our project. We have a handful of distributed energy resources that have met this level of design consideration. The central element here is cogeneration. It takes the biogas from an anaerobic digester, which would be on the plant, and it runs it through a combined heat and power generator. This allows us to utilize up to 80% of the embodied energy compared to about 40% when you're only utilizing heat or power. The solid effluent from a codigester can flow into a pyrolysis chamber, heating the solids to 800 degrees Fahrenheit. From pyrolysis, we can get biofuel to fuel trucks as a form of clean diesel and grade A biosolids. Our microgrid design will also look to be a community design that incorporates the surrounding neighborhood. Next slide. Thank you.
All right, so for us to undergo such a co-digestion program, like John mentioned, we'll have to look at some incoming food waste, energy. Those systems are generally divided into three: the commercial, fats, oil, gases, fogs, pretty opaque system. We're not gonna really look at that one too much, keep an eye on it, but otherwise the rest of the commercial and the residential is really our main focus, and we wanna get those streams into our bioslurry at the Right now, there's a lot of obstacles in the way. We have legislation, Local Law 199, that's completely rewriting the commercial distribution system, as well as citizens. People need to learn how to separate their food waste, and DSNY's got to get it to us. So that's the goal. And then in the upper right, we see controlled environment agriculture. That'll give us some influence to our bioslurry as well. And those systems are programmatic elements that we're proposing that Georgina is going to talk about a little bit later. Food hub stuff at the plant, at the campus, I should say. Sorry. Next slide. Relevant case studies here. EB Mud is the kind of the gold standard, the first U.S. net zero. Closer to home, upper left, we see Newtown Creek is doing anaerobic co-digestion right now, the first in New York City. Lower left, we see Riverbank State Park right there at the end of 145th. It's a great study, and there's a WRF right underneath the park there. It's a really good study of community integration. Upper right, Willamette, Oregon. Oregon's been doing some cool things with getting public involvement. And lower right, we see one that's kind of happening right now. It's a smaller thing, but they're seeing some positive results from spent brewers grains, controlling effluent. In other words, getting pollution control by using brewer grains. So we're thinking about maybe putting a brewery out on our campus. Next slide.
Right. So going back to the community for a moment before we get into the food hub, East New York is a food desert and an economically stressed area with high unemployment and high obesity rates and low educational attainment. So taking into consideration these socioeconomic conditions, we want to propose a food hub that will help improve these issues by bringing in food production using advanced agricultural technologies, adding value to the produce that we get, and then through food manufacturing and food production, and so that we will be able to provide high quality food to the community while also creating opportunities for jobs and education and research. And in order to understand a little bit more about next generation urban food systems, we're looking at a couple of case studies. One is the Plant Chicago, which is a net zero closed loop system that incorporates 16 different food businesses, and they have been very successful at delivering high quality food to their community. The other one is Arrow Farms in New Jersey, which is the largest vertical indoor vertical farm in the world. And what's really special about them is their smart aeroponics system, which allows them to monitor and control their crops and be very efficient. And Abraham is going to talk to you about some other case studies.
Yes. So some of the relevant case studies that we found, especially as we consider next generation water resource recovery facilities or campuses, we are looking into the integration of Industry 4.0, which has to do with big data, artificial intelligence, robotics, and automation. And I won't get much into this, but it's more on data monitoring, augmented reality, and additive manufacturing technology from preliminary stages. We want to take advantage of the potential, the ecological potential of Jamaica Bay as a science lab. And we've looked into other case studies, especially the Science and Resiliency Institute of Jamaica Bay, which could be potentially a stakeholder at our facility. Next. Other case studies, again, it's on floating wetland systems that can serve as potential tertiary treatment for the combined sewage overflow or water effluents coming from the wastewater treatment plant into Hendricks Creek. And this can, again, provide aquatic and terrestrial biodiversity, and while also cleaning the water.
So our ultimate goal is we want to deliver a conceptual design of a next generation WRF campus that integrates into the water, energy, and food nexus and is able to bring energy efficiency, community integration, and ecosystem benefits to the community of East New York. This is our presentation. Thank you.
Thanks.
Great, thanks all. It's weird to not have clapping, I'm sorry.
Doesn't clap. Everyone unmute your audio so we can hear the claps. It's fine. Just very briefly.
If the guest reviewers could unmute themselves, and I'll start with Jen again. Do you have any questions or comments?
Hi everyone, that was a very nice presentation. It's also very huge. And I'm having a little bit of trouble getting my head around like the specific deliverable. You talk about a 3D conceptual design of a next generation WRF campus. What does that really mean, and how is that something you guys can achieve in one more semester? Because I think that's really key. There's a ton of good ideas, but what are you really gonna do with them?
Does anybody want to field this question who's not me?
Well, that's our, and it sounds so lovely and pastoral there, Jen. I love the birds in the background. Thank you. That is our challenge. I mean, our first semester has really been to research a lot of these programmatic elements. The main core mission for DEP is energy neutrality and community integration. Yeah. So those are the systems that we need to concentrate on, and those are what we have been. Now, a brewery can help with that, but is that going too far? That is going to be our challenge, but our ultimate deliverable is a picture of what this site looks like, including the...
Can I jump in for a second, Jay?
Yeah, jump in.
So I think, let me get back to the core question. I'm not sure if I remember exactly correctly. It has been a stressful week, I'm sure, as you can imagine. So I think the idea was just what's our core deliverable, I think is the question. So basically, the way I imagine this project is a kind of almost like a design build, right? Like we found these programmatic elements that we can now explore further and also really get down to the numbers of what's really applicable to our site. Like a lot of these energy generators that I talked about, I'm pretty sure most of them will fit and will work, but I definitely have to get down and weed through all like with a finer tooth comb and say how much is the cost savings. All this should be in our final report. Also, the MicroGrid component should have other resiliency developed design metrics built into it. We're going to run on Simulink, which is a MATLAB add-on, and that will enable us to simulate our microgrid, and we'll be able to generate like cost savings, other ancillary benefits, the financials of where those ancillary benefits accrue value for the utility as well as for the campus. And from there, I think we're able to use those cost savings to bring in these other synergistic elements. I think it's very clear that the food waste stream feeds really well into co-digestion. If that's not clear, please stop me and we can discuss that. But it is, I think, to me, a very clear connection. And then from food waste to food is also a very clear connection. So it is bridging that gap and making that understandable. But I think we're able to do that in the paper, maybe more so than this presentation, but I think it's something we have to do better in the next presentation, if that makes any sense.
Yeah, this is a very big project, and it's difficult to convey everything that we want to do. But the main goal is to provide DEP with a vision of what a next generation water recovery facility should look like. And our next steps are around transporting our conceptual elements into physical reality and delivering hopefully a 3D rendering of what these extended campus facilities could look like.
Yeah, that is correct.
Yeah, but it is.
I'll say one more thing and yield the
Please.
floor. I think
Oh, good luck.
what's really key here is the numbers again, right? Like, how much food waste do you need for this, and where does it come from, right? Food waste generation. There are numbers to that.
I think
How much energy is produced? Breweries, they yield a certain amount of brewery waste. Yada yada yada. These are all numeric, and they're very specific. And to get the math right, you have to understand all of those considerations. And are there like byproducts that are not usable that are challenging in your premise here? But I will yield the floor.
Yeah, I think that's a very valid critique, or it's a consideration for us to consider. But I just don't think this is really the place for us to break down the numerics so much. I think like since the project's so big, we really have to give you guys the landscape more than the quantitative data, especially in this space, because we only have 10 minutes to give. If that makes any sense. Yeah.
Kevin, questions or comments?
I mean, I'll just back up Jen. I think it's not necessarily a criticism. It's, almost every capstone tends to, like at the beginning, sort of flare out to think of there are so many interesting, and then to narrow back down again. So, I mean, it's perfectly good that the next part of your research or, thinking will be, we've got this, like, it feels like a Christmas tree with just so many different decorations hanging from it, and I'm not clear which are the ones that are kind of just nice shiny things and which are the really key where you're going to be going deep. So, and I mean, because it is too deep of a project. I mean, you keep saying it's a really big project. It is too big for one team to do in one capstone, and that's fine. But just, I'd rather you go deep in one slice than.
Yeah, well.